Well, ladies and gentlemen, we have a new radiator. So we can go ahead and get Mr. Leaky out of here and throw this in and verify the damage, I guess, is another thing. It's going to be a little annoying to take all the fittings off of this radiator we already had set up, but, you know, probably 10 minutes of work. And we'll be right back and let you know how it goes. All right, guys, I've got the damaged unit off now. That only took about 2 minutes, and I've been able to inspect it, and I could see that it was probably my fault that this got damaged. If you look right in there, I think that at one point when I had the radiator facing the other direction, I must have over tightened a screw where it went through the front and tightened all the way into the radiator and damaged the cores here. So you know, stuff happens. Oops, sorry about that. Stuff happens and we make mistakes. So I'm just going to move this hardware, the fittings off of this unit onto the new one, and we'll see if we can get this thing started again. Now, I just want to remind you guys, I was very sure that this was going to leak. Not from the radiator, but from these fittings. So once we get this all buttoned up with the radiator, there's still a good chance it's going to leak again. But thus is the pains of dealing with such high-end stuff. Anyway. Okay, guys, this is a note basically to people that might be doing stuff like this, or I'm just complaining, okay? You see how there is a stop on the threading here on the screw? This is the screw that comes with the Thermaltake 240mm radiator. I think that Thermaltake could have done a better job with the screws because, yes, I over-tightened it, but when you're tightening them, there's no way to know how deep you are into that threading. Why didn't they just make this shorter so that there's no chance it could ever damage the radiator? All right, guys, we're hooked up. So I've got a power supply tester on the power supply, and I need to connect that to power and then flip the switch, and all of a sudden we'll hear the beeping noises from the power supply tester, which will let the pump run, but we're gonna fill some distilled water into the system first to make sure there's no leaks again. So let's do that. This time I put it into a water bottle. Watching the stream of water on this top pipe is actually really cool. I'm gonna kind of adjust you guys a little bit so you can get a close-up of it. It's like a string of water. You see that? It's moving. It's so creepy. Okay, so it's actually getting pretty full at the top of the radiator. I do think that there are some, like this tube does not seem to have any water in it. So there's probably still a lot of air bubbles in the system. And this reservoir is not even close to full. So I do think it's a good time to get the pump running though, to get a lot of the air bubbles out of the system and to just check for the leaks. So, well, I guess here goes nothing, guys. All right, guys, I was just about to fire up the system here to do the test, and I just sprung a leak. And if you're wanting to know if I'm angry, yeah, I'm a little bit pissed off right now because the leak is coming from the brand new radiator, and it's not coming from fittings. It's coming from the fins again. So more fins problems. And when I did the tightening on these fans right here with these screws, I actually did it by hand really lightly to be sure that I wouldn't penetrate through the fins. And you can see that the leak is actually coming from, I'm going to take you off this tripod. The leak is coming from this back side and maybe the front side too. Maybe both. You see how the fins are just straight up leaking water? I at first thought was like, oh, it must be coming from up here, you know, where the fitting meets, but there's no leak there. It's coming right out of the fins. It's really crazy. So really sucks. You can see there's water leaking down to the bottom. All right, guys, I've got an update here. So this is the new radiator, right? And I have it out of the case, getting ready to send it back. And I decided I want to see exactly where the spot was that it's leaking from, because I knew it wasn't going to be from over tightening screws into the fins. And yep, I checked that. I was correct. I definitely didn't even come close to over tightening any fins. So I took the trusty electric duster and dusted all the water out of it. Wiped it all off, got it completely dry, and then I was like, oh, maybe this thing is only supposed to go one way. Like maybe I have it upside down, and this radiator, I have these two holes up here at the top. Maybe they're supposed to be at the bottom for the way that this radiator is supposed to be installed. So I tried filling it with water, and it kept leaking, and I actually came down to the culprit of these right here. Just these are where all the water is leaking from, as crazy as that sounds. So they're confirmed. It was those plastic stoppers. These guys, they have like a little flathead screwdriver slot on top. They're just plastic. There's no rubber gaskets. I am an idiot. I should have probably read the instructions. Completely my fault. And this has all the like metal with the rubber O-ring seals on it. So this is not leaking now. We can go back to where we were. And I'm sure some of you guys might be curious, was this one bad too from over tightening the screws? I'm going to check that actually first. All right, guys, this is the damaged original 240. And as you can see, it is not leaking. So it was 100% those plastic stopper things not having any sort of a rubber O-ring gasket seal or whatever. And I'm just an idiot. So nothing to do with over tightening the fans. And Thermaltake, I am not mad at you. I take back everything I said about your products. And I probably should have read the instructions. I have not checked the instructions to see if they told us to do that. But I think for the sake of making me look like a bigger idiot, we should look, because this is the instructions. To ensure a clean loop, flush and rinse your radiators and water blocks with distilled water prior to use. Do not use tap water, okay? It is strongly recommended to use market-provided premixed coolant, okay? Before storing your water cooling products, please clean, rinse, and dry. I actually thought it would say something about removing these guys right here. Does not say anything about removing them. There's one more piece of paper though. There's a very small one right here. Product warranty. This one doesn't say anything. So in defense of myself, I will say that I think it was a major boo-boo of Thermaltake to not mention that you need to remove those plastic stopper thinger merbobbers. Let's put it back together and turn it on. All right, so back to filling it up with water again. We leaked out a bunch of water because of the leak, and we are now going to fill all the reservoirs back up again and spill a lot. That's full again. Okay, well, if we turn the pump on, you can see that this is actually really high, and that's good because that's where the pump's going to circulate. Yeah. So I think it's time to turn the pump on.
All right.
Which is just basically, I think all I need to do is flip the switch down here, and that should be it. Yep. All right, watch for leaks. Okay, so far no leaks, but I'm debating whether or not to kill it and then fill it again. Kill it and fill it. Let's kill it and fill it. Okay. All right, people. I got to a point where I was kind of hitting a brick wall because we couldn't add any more fluid or water into the system. We couldn't, so because we couldn't fill it up anymore, it was like the angles and everything of the tubing. We couldn't get the reservoir filled up all the way, which means that since this wasn't getting any water right here, it wouldn't complete like the full circle for the pump to do the whole, move the water all the way through. And so it wasn't working. That's bad, right? The good news is we weren't having any major leaks despite all these towels everywhere. That was just from me overflowing when I'm filling it up. So this is the idea, and it's a little bit crazy. I hooked up one tube here on the top of the where I was filling, and another tube out the other side just so I can see if I'm overfilling, and I'm gonna blow through this right here, and then we're gonna watch it fill the whole system, and if it gets too high, we'll see it coming up on this back tube. So yeah, here we go. I'm gonna put down the tripod, and hopefully we see this fill up a little bit right here. Okay, that was already a fail. It actually made the air. It pushed the air only to back here.
Right.
So, all right, guys. An update. Off camera, we've been running the system. It is getting full. It's just taking a really long time to get the reservoir filled up all the way. But it's getting there, as you can see right here with that line. Sorry, right like that. So we just keep running the system and releasing a little bit of air here and there, and then filling more, and we're just doing it over and over. But let's run the system with you guys. I'm gonna turn it on here. We're getting a lot of air bubbles in the video card right now, the GPU water block, but it's actually better. That's a lot better than it was before. So I think it's just slowly but surely adding more water, getting more air out, and eventually we'll be there. But we don't have any leaks right now, so that's really good. Knock on wood. All right, dudes and dudettes. We have a fully functioning loop here with just distilled water, and I'm not using colored stuff right now. So let's see, how do I change my tripod? There we go. I'm just gonna kind of point out a couple little things here for all you people that are interested in water cooling your own systems. So I do think I actually didn't know what airflow the pump was going, like the directions of the flow. I wasn't sure if the pump was going to pump like this way or this way. It is pumping this way, so that means that the pump right here is pushing the water up here, and it comes to this guy right there, which goes to this up to here, and then comes up high. If I can adjust the camera, sorry, it's a little too stiff. That's what she said. So that comes up to here, which comes to the video card, and I think the video card may be the opposite direction of what EK wants the water flow to be, because there's an air bubble that I haven't been able to get to go away right here. And I think that's just simply because the water flow, it's not designed to go up that way. It's designed for the water to come this way and around and come back through there. So not a big deal to me. I think some really picky people would be like, oh, okay, I got to start from scratch. I kind of just don't care enough, guys. And I did have something like that happen on a previous build. On a GTX 970 that was water cooled, and that air bubble, that air pocket actually eventually worked its way out, and it filled itself over a long period of time. So, and this isn't even, this is just diluted water, or distilled water. I still need to use regular stuff like this. You know, we're gonna put orange stuff in, but this is like the type of coolant we're gonna be using, but in the orange color. So anyway, continuing the flow, it comes out of the GPU water block here, goes up into the CPU, and then you can see the same problem. There's a little air bubble, little tiny guy up there, top left corner, and that is a similar problem where I'm going the wrong direction, against the grain, whatever you want to call it, for what EK wants you to do. And Jay's 2 cents had some videos about this. It doesn't really matter. It's not a big deal. It's not going to hurt my performance of the cooling. But as you can see, this the CPU water block exits to the VRM water block that's built into the motherboard. Let me adjust this tripod up a little bit higher, which comes out right here and goes up to the big water radiator at the top. The radiator circulates and then comes out the back here, which scoots its way along back into the waterway, which then goes through the waterway and comes back up to here, which then goes to the next radiator back here, and then exits here back into the waterway, which completes the full circle to come down back around through the pump. The full loop is working, obviously. Just, if there's a button on the pump to say reverse, go the other direction. And I don't even know if the waterway would want to go. Maybe there's a reason why you don't want the waterway to go the other direction, but no big deal. I'm fine with this. There's a couple little changes I'll probably make over time. I may change this right here to look like one of these, this black 90 degree, instead of coming out like this. Because I do have another black 90 degree, and it would just kind of look a little bit more uniform, I guess. But like there's a big air pocket kind of at the top of the reservoir, and I don't think that's ever going to go away. I'm not able to figure out a way to fill that higher. I don't see the way to do it. So that's kind of what happens with the system like this at the waterway. If there was a filling hole from the top of the waterway, then yeah, I'm pretty sure I could figure that out. But there is not a hole in the top of the waterway to fill the waterway itself. So yeah, everything's working. I don't know what the temperatures are like. I don't have a monitor on there. The system's not on. This is just running off the power supply connected to a power supply tester. That is the annoying beeping noise you're hearing. Sorry, not sorry. That's pretty much the end of this video. We're just gonna leave this running for a while and hope it doesn't leak. And if it doesn't leak, then we can kind of move into the next steps. Fill up with the correct coolant. Get all the wiring done on the back of the case. I'm not looking forward to that. And then we can start overclocking and getting Windows set up and all that good stuff. So still a lot of steps to go here, guys, but this is a lot of progress today. So thanks for sticking with us, and look forward to the next video.